Okay, so, alright, number 4. We have a ladder. It's 26 feet long. That ladder is not going to magically shrink or increase in length. It's going to stay 26 feet. It's leaning against the wall. The lower end of the wall, right, of this ladder is moving away, right, at a rate of 5 feet per second. It's saying how fast is the height of the top, right? How fast is this changing, right? If this is sliding out further, this guy has to be moving down, right? It's going to be negative. How fast is the height of the top changing? When the lower end, right? So at a specific point in time. When this is 10 feet from the wall. Okay. Right? This is different than the other problems because I don't give you all an equation. But let's kind of just see what information we can get out of it. What's the shape that we get with this? We get a triangle, right? Specifically a right triangle, right? Okay. So we want to know the rate that this is moving. How fast is it moving from the top? So let's say that this is, let's call this the length. Okay. I'll call this guy H, right, for the height of it. And then this one, we can call it X if you want. And the reason why I'm giving 2 letters is that I have 2 moving parts. I have 2 things that are changing, right? My height's moving. The height is not the same at any given time, and neither is how far out it is. But what's the relationship of these sides given that it's the right triangle? And I know the ladder is 26 feet. Right, from Pythagorean. I bet you all thought you'd never see him again. Okay. The height and how far out it is changes at any given time. Both of these guys are some function of time. I just don't know the actual equation. And if I want their rate of change with time, right, both of them have their own relationship. Okay. I know some information. I want, which of these do I want in terms of the rates of change? dH dt. When what's happening? Right? When the lower end is 10 feet from the wall, so in terms of the letters, I know that x is going to be equal to 10, right? What else do I know? dx dt is 5 feet per second. Okay, so I want the derivative of this guy, this whole thing. Right, the derivative of this side has to be the same as the derivative of that side. They're equal. But these are functions that depend on other functions. The right side's pretty easy to do. What's the derivative of just a number? 0? Right, that has to equal 0. And then I'll do the derivative like I normally would for a variable, 2h. But the thing is, that h depends on something else, so what will you do? Right, dH dt. Okay, what else are you going to do for this? 2x dx dt. Okay. I know x. I know dx dt. I want dH dt. But the thing is, I still have something I don't know right now. I want to know what h is doing at this time. Is there a way for me to know that? Yeah, just plug in 10. I know that h squared, when it's 10 here, will look like this. What will you get from h when you solve that? 20, I'm sorry? 24? Okay, so now it's just a matter of solving by plugging everything in. I have 2, my h is 24 at this point of time. I want the dh dt. I have that x is 10, and I know that this is 5. Okay. And so just solve for dh dt. Okay, so take a second, just do that algebra. You have 48 dh dt equals, bless you, I'm going to move this over, minus 100. What will you just do after that? Divide by 48. Okay, and so for your dh dt, you can just round 2 decimal places for me. Okay, and then what are the units on this? Good. Okay, this is the hardest this could ever get for what we're doing. Are there questions with...
How'd you get 24 for that age?
Yeah, when you... No. We solved for the h using the original. Yeah, using the original.
Got it.
Okay. All right, so this idea of being able to come up with an answer for rates of change even though we don't have an explicit equation. So for example, if you're working with your business, you're doing that revenue model, you know how much you sold, how much like it changed for that day, like yesterday you sold this many units, next day you sold this many units. You don't need an equation for the derivative, you just have a number, and you can predict what the change will be for a third variable like time. The mechanics of something like this, right? So this idea of being able to do a derivative without knowing the explicit equation or implicit. Just the mechanics of it. Okay. Basically depends on a chain rule, right? Okay. So another way that we use implicit differentiation is when we're given a model, right? Maybe the variables that we want are there, but in terms of wanting something like dy dx, right? I don't have an equation for y equals to say what the derivative will equal. There's some kind of implicit relationship between x and y. It's just I don't have it written in a way where I can see it. That's another way we're going to use the chain rule here. And so y is some function of x, y equals. It's just my equation doesn't look like y equals. It's intricately involved at one side. And I want dy dx. I just can't see how that equation looks the way it's given. So the way I go about doing it is I do the derivative, right? These two sides are equal. So derivative of this side has to equal derivative of that side. Derivative of a number will be 0. I go to do this derivative, right? I have x times y. I do the derivative like I normally would. What's going on here? Product, so I need product rule. Okay. Derivative of x, what would you get from that? 1. The other one stays the same. Then I need to switch. The x will stay the same. I need the derivative of y. It would normally be that, but what I don't know what y equals, so what will you write? dy dx. Okay. So we're still able to do the derivative without writing the equation as y equals. Okay. Solve for dy dx. What does dy dx equal? I want to get it by itself. I have stuff getting added to it and getting multiplied to it, so what would you do to get the dy dx by itself? We're adding y, so right, subtract the y. And then I'm multiplying it by an x. Mm-hmm. Okay. Another example, so let's say I had I'm interested in finding dy over dx for whatever application that I'm doing. It's just I don't have an explicit equation for what y is equal to. It's not y equals, so that when I do the derivative of both sides, I'm done, right? Y is some function of x. There's some relationship. I just don't know explicitly what that is. Right? But I can still answer this question because I know how to use chain rule. I don't need the explicit equation. I know how it works, and so I'll just use a placeholder for the derivative, dy dx. Right? Doing the derivative like we normally would. This side is the same as the left side, so derivative of number is 0. What would you get on the left-hand side? 3x squared. How about here? 3y squared. Careful. Yeah, times, right? We tack on whatever that derivative is, because I know how to use chain rule. I need it here. I just don't know what dy dx is right now. Okay? But now I have an equation. I want to get the dy dx by itself, so the rest of it is algebra from here. What will you do to get it by itself? Subtract the 3x squared, right? And then divide by the... I want to get the dy dx by itself. I'm multiplying by 3y squared, so I'll divide it out. We could simplify out the minus the 3's. I'm not going to be like that worried about simplifying, but that kind of basic stuff you all can do, but not more than that. Okay. So dy dx, that's what the derivative would be. Another example. Listen. We want the change in y over change in x. That's the answer we're interested in finding. There's some relationship between y and x, but my equation doesn't look like a y equals for me to see that, right? But I still know how how to take advantage of the rules to get the derivative. They're equal, so derivative of each side will be equal to the other. Derivative of a number is always 0. What will you get on the left-hand side? So hold on, 1 over y? And then, yeah, times the dy dx. There's some function inside another function. I don't know what it is. I need to tack on the derivative of the inside. And then what will you get for this derivative? E to the x. I want to know what dy dx equals, so let's take a second, solve for dy dx. I'm adding e to the x to it, so I'll subtract that off the other side. Okay, last step, what will you get for dy dx equals? Step it up a little more.